We looked at the sampling distribution of mean. This is the sampling distribution of proportion. So we will look at the sampling distribution of sample proportion to be precise, and we can compute probabilities using the sample proportion. So suppose we have a sample of size n, and we have x, which is the number of individuals or number of outcomes that pertain to a specific event or a specific characteristic. Then the sample proportion is denoted by p hat, which is simply x over n. So this is pretty much the definition of probability. So if you take the number of outcomes specific to an event and we divide by the sample size or the total number of outcomes, we end up getting a sample proportion, which is pretty much the definition of probability. So, how do we compute a sample proportion? So here's an example. In a Quinnipiac University poll conducted in May of 2008, 1,745 registered voters nationwide were asked whether they approved of the way George W. Bush is handling the economy. 349 responded yes, obtain a point estimate for the proportion of registered voters who approve of the way George W. Bush is handling the economy. So here the event, the specific event, is registered voters who approve of the way George W. Bush is handling the economy. And particularly that would mean that they responded yes, that George W. Bush did handle the economy well, and we approved it. So P hat is the point estimate for sample proportion, and it is simply given by x divided by n. X is the number of outcomes specific to an event, and that event here is the number of registered voters who approve of the way George W. Bush is handling the economy, divided by the total, which is the sample size. So 349 people responded yes, that he is handling it well. So 349 divided by 1,745. That would be the sample proportion. And that value is 0.2. So just like the sampling distribution of mean, P hat is a statistic. P hat is the sample proportion, so the distribution of a statistic is called a sampling distribution, so we call it here the sampling distribution of P hat. So if we have a random sample of size n with population proportion p, the shape of the sampling distribution of P hat is approximately normal, provided this condition is satisfied. This is quite important, and p times 1 minus p is greater than or equal to 10. So the mean of the sampling distribution would simply be the proportion P, and the standard deviation of the sampling distribution of P hat, which is the standard error, or SE of P hat, is given by that formula, square root of P times 1 minus P divided by N. So that formula would work if the sampled values are independent. So if we sample from finite populations, then typically the assumption will hold, and you can verify it by checking that the sample size is no more than 5% of the population size. So this condition is also important regardless whether NP times 1 minus P is greater than or equal to 10. The mean of the sampling distribution is P hat, and the standard deviation is always that formula right there. So here is an example. According to a time poll conducted in June of 2008, 42% of registered voters believed that gay and lesbian couples should be allowed to marry. So here should be allowed to marry would simply be the event of interest, that is, that specific event. So we get a sample and we have 50 voters. So we can write it down, the sample size is 50, and determine which voters believe that gay and lesbian couples should be allowed to marry. So 42% said that they are perfectly fine with gay and lesbian couples are allowed to, with the fact that they can be married. So X in this case is simply 42% of 50. And that value is 21. So, how did I get that? We know P hat is X over N, and in the problem, P hat is given that 42% of registered voters believed that gay and lesbian couples should be allowed to marry. So, P hat then would equal to X over N, which would imply X is equal to P hat times N. All I did is multiply both sides by N. So that would give us 0.42 or 42% multiplied by 50, and that is the answer I had, and that was 21. So now we have to find the sampling distribution of the sample proportion, which is P hat and it is important that we check the condition that N times P times 1 minus P is greater than or equal to 10. N here is 50, P is 0.42, and 1 minus 0.42, and that would be NP times 1 minus P. So that would be 21 times 0.58, and we get 12.18, which is greater than 10, so our condition checks out. Now, we have p hat, the condition works, so now we could find the standard error of p hat. And that is given by the formula square root of p times 1 minus p over n. P is 0.42 times 1 minus p, 1 minus 0.42, divided by n, which is 50. And we have to take the square root. Do not forget to take the square root. And if we take the square root, we end up getting 0.0697. So what is the sampling distribution? The sampling distribution of the sample proportion is normally distributed, and we can say that it is normally distributed because our condition over there works. With mean p hat, and that p hat is 0.42, and standard error equal to 0.0697. So we can compute probabilities for the sample proportion knowing the fact that it has a normal distribution. So in this problem, according to the Centers for Disease Control and Prevention, 18.8% of school-age children aged 6 to 11 years were overweight in 2004. And part A says in a random sample of 90 school-age children aged 6 to 11 years, what is the probability that at least 19% are overweight? So, we know that 18.8% of school-age children aged 6 to 11 years were overweight. So P hat, according to CDC, is 18.8%, which is 0.188. So that would be the sample proportion, and the standard error for that is equal to square root of p hat times 1 minus p hat over n. So you can put p hat or p in this case as long as you put in the right values. So square root of 1.88 times 1 minus 0.88 divided by n, which is 90. The reason being, we are looking at part A and it says 90 school-age children. So perhaps we should put it as P because it is given information, so the CDC value is 0.188. So it is given to us. So we will just put it as P. So 0.188 times 1 minus 0.188 divided by 90. So we will get square root of 0.0017, which would be equal to 0.0412. So that said, the question wants to know the probability that at least 19% are overweight. So out of those 90, we want to find the proportion to be greater than or equal to 0.19, which is 19%. We know that the proportion has a mean of 0.188 and has a standard error, which is the standard deviation of 0.0412. And we want to find the probability that P is greater than or equal to 0.19. Just right there. So we start at 0.19 using normal CDF. We end at E99. The mean is 0.188 and the standard deviation is 0.0412. And that standard deviation is simply the standard error. So the probability is 0.4806. So we could move on to part B. So suppose a random sample of 90 school-age children aged 6 to 11 years results in 24 overweight children. What might you conclude? So right now we have another estimate which states 24 out of 90 children aged 6 to 11 years are overweight. So that probability is 0.2667. So what are the chances that the probability, that the proportion be greater than or equal to 0.2667? In other words, 26.67% or more out of those 90 school-age children are overweight. So that would be the probability that at least 26.67% of school-age children And how did we get that number? That number is 24 out of 90 are overweight. And what are the chances of that happening? So the probability of that happening, we could find it using normal CDF, because we know that the sample proportion has a bell-shaped curve with mean 0.188 and a standard error of 0.0412. 18.8% is in the middle, 26.67 is right over there. So we want to find that area, and that area is likely to be quite small. So we start at 0.2667 and we end at E99. The mean is 0.188 and the standard deviation is 0.0412, which is the standard error of proportion. So that value happens to be 0.0276. In other words, 2.76%. And that is a very small percent. So for us to make a statement that 24, the event that 24 out of 90 students, not students, excuse me, school-age children are overweight seems to be unusual. It's a very small probability. So going back to the gay and lesbian couples and their marriage problem, we now have 500 voters, and we want to describe the sampling distribution of the sample proportion. So we know P is 0.42 because 42% of registered voters believed that gay and lesbian couples should be allowed to marry. So that would imply that if we pick 500 voters, in other words, n is 500, the standard error would then become the value that we get from the formula, which I would write in a bit. The mean would remain the same. In other words, the sample proportion for these 500 voters would still be the same. So P would remain at 0.42, which is the mean. But the standard error, which is the standard deviation of the sample proportion, would be P times 1 minus P divided by N. So the standard error is 0.42 times 0.58 divided by 500. And do not forget to take the square root. So we get 0.0221. So we have to do this check in order to guarantee a normal distribution. So what is that check? Now, if this condition fails, all we can conclude is that the normal distribution assumption is not going to hold. But if this condition, NP times 1 minus P is greater than or equal to 10 holds, then we would have a normal distribution. So, what is N? N is 500, P is 0.42, and this is definitely going to be greater than 10. So that value is 121.8, definitely greater than 10. So we can go with a normal distribution assumption. So what is our conclusion? The conclusion here is that the sampling distribution for the sample proportion, where n equals 500, is normally distributed. I'm running out of space. With p, which is the mean, equal to 0.42, and standard deviation, or the standard error, SE for p, equal to 0.0221. And we can say that normal distribution holds because that condition is satisfied. So we want to know the probability that at least 15% of the 500 voters believe that gay and lesbian couples should be allowed to marry. In other words, we want to find the probability P is greater than 0.15, which is 15%. We know that the proportion is normally distributed with mean 0.42, and the standard error, or the standard deviation in this case, is 0.0021. 0.15 is somewhere over there, and we would like to find that probability of P greater than or equal to 0.15, which is the same as the probability of P greater than 0.15 for normal distributions. So we can make use of normal CDF to find this probability. So the lower endpoint here is 0.15. The upper endpoint is infinity, or positive E99. So we plug in 0.15, comma, E99, comma, the mean, which is 0.42, and the standard deviation, 0.0221. And that standard deviation is simply the standard error for P, and the answer ends up being 1. In other words, that the chances that at least 15% out of the 500 voters would believe that gay and lesbian couples should be allowed to marry is certain. So now we want to find the probability that at most 100 out of 500 voters believe that gay and lesbian couples should be allowed to marry. In other words, probability that the proportion is less than or equal to 100 over 500, which is the probability that P is less than or equal to 0.2. which is the same as the probability P is less than 0.2. So there we have a bell curve, and we have 0.42, and the standard error is 0.02, which would mean 0.2 somewhere over there. So we would have the starting value, or the lower endpoint, at negative infinity, or negative E99. The upper endpoint is 0.2, because we're trying to find an at most probability. So we make use of the calculator. The starting value is negative E99. The ending value is 0.2, the mean is 0.42, and the standard deviation is 0.0221. So, which happens to be 0. In other words, for us to say 22%, only 22% or less out of the 500 voters we have would approve of gay and lesbian couples is unlikely. It's just impossible based on the sample, based on the information we have. So in the next problem, we have the probability that between 50 and 250 voters out of the 500 voters believe that gay and lesbian couples should be allowed to marry. So what we want to find is the probability that 50 out of the 500 is less than the proportion, which is less than 250 out of 500. So the proportion has to be between this value, which is 50 out of 500, and that value, 250 out of 500. Keep in mind, this goes back to the concept of x over n. X over n. The x value here is the number of voters who believe that gay and lesbian couples should be allowed to marry. So 50 out of 500 is 0.1 and 250 out of 500 is 0.5. We know, according to the sampling distribution that we wrote, the sampling distribution is normal, the mean is 0.42, the standard error for proportion is 0.0221. I just want to make sure. And 0.1 is somewhere over here, and 0.5 perhaps is over there. This doesn't have to be exact. We are doing this just to determine the lower and upper endpoints. The lower endpoint here is 0.1. The upper endpoint is 0.5. So the probability can be found using normal CDF. You start as 0.1, you end at 0.5, the mean is 0.42, and the standard deviation is 0.0221. And the answer is 0.9998. In other words, there is a 99.98% chance that between 100 and 250 voters out of the 500 voters would approve of gay and lesbian couples getting married.